So this is our special order and technique for graphing sine and cosine when you have A, B, C, and D. Or if you're missing one, you still can use it. You're going to start with your D value. So the very first thing you're going to look at, what's your D value? That's going to become your center line. Then we're going to use our amplitude, because amplitude is the distance from a center line to a max and center line to a min. We're going to use that amplitude to get our max and min. If you weren't here at the end of last class, this is on a video, so you can get it later. Then you go to your B value and use the formula that the period is 2 pi over your B value. Calculate your new period and divide it into 4 equal sections. The dash means that we'll graph it with a dotted line, and finally we'll do the phase shift. So what does that mean if we have a question like this? So off to the side. I'm going to use this method, and as I do things, I'll check things off. So first of all, I'm going to start with my D value. My D value is 1. So what does that mean? Is that at 1, I'm going to take out a red pen, draw a dotted line at y equals 1. That's all you have to do for the D part. Draw your center line. Next, the A. My A value is 3. That's my amplitude. Amplitude is the distance from your center line to a maximum. So if I go up 3, I would go up to 4. If I would go down 3, I would go down to -2. That's all we have to do for the A value, is label our max and our min. Next, our B value. And in green over here, I did. My B value is 2, which means my period is going to be 2 pi divided by 2. Because the normal period for sine and cosine is 2 pi. That B value of 2 is a horizontal compression by a half, meaning your period is going to get multiplied by half. So that's why we would do 2 pi divided by 2. And so I go on my axis and I mark pi and divide it into 4 equal sections. And label each of these sections. I always start with the middle one, half of pi, pi over 2. Then I cut that one in half. This would be pi over 4. And then the third one, I just say, well, if one of them is pi over 4, this is 3 of whatever the first one is, so this will be 3 pi over 4. And that's all we do for the B value. Now we draw our graph. The dash says draw your graph without a phase shift. This is a cos graph. Where does a cos graph start? A cos graph starts at a maximum. So you would go, and because you've nicely divided in 4 equal sections, you go maximum to center line, to minimum, to center line, to maximum. And in a dotted line, this is the graph without the shift. And so the dash, I have to check off, that's what it means in DAB C. The dash means something. We actually have to draw it with a dotted line. And then finally, we have minus pi over 4, which is a shift pi over 4 to the right. Notice pi over 4 is already labeled, which is really nice. So now we're going to take each of our points, and we're going to shift them 1 ticky mark, because that's pi over 4, to the right. And that's how you can graph it all at once without having to do a bunch of points and do a bunch of mental math. This is the shortcut for graphing sine and cosine. Okay, we'll do another example. Are we ready? Almost. again, I'm going to write, those are my steps that I'm going to write off to the side. I'll check them off as we do them. First, we start with our d value. In this case, our d value is -2, so I go to -2, I draw a dotted line. That's my sinusoidal axis, or my center line. I draw a dotted line at y equals -2. My amplitude is 4, so I'll check off. That's all you have to do for d. Done. Next, my amplitude is -4, which means my a value is -4. Your amplitude is always positive because it's measuring up and measuring down. It's going to be 4, so I need to go up 4. 1, 2, 3, 4. A maximum of 2, down 4. 1, 2, 3, 4. A minimum of -6. And that's all we need to do for our a value. Our b value, we have to calculate our period. And your period is always going to be 2 pi divided by your b value. And in this case, our b value is 3. So we go on our x-axis and somewhere mark 2 pi over 3, because that's one period, and divide it into 4 equal sections. Easiest to do the middle section first. Cut that in half. You'd have pi over 2. Cut it in half again. You'd have pi over 6. And the third one would be 1, 2, 3 pi over 6s. You could reduce this to pi over 2 if you wanted to, but you could leave it. I'm leaving it as 3 pi over 6 just so you get that idea. You're counting pi over 6s. And there would be 3 of them to that third tiki mark. And that's all we do for our b value. Next, we draw the graph, dotted line, without the phase shift. So now, what kind of graph is it? It's a sine graph, but it's a negative sine graph. That negative is a vertical reflection. So where does a sine graph normally start? Normally starts in the middle going up, but if you had a vertical reflection, it would start in the middle, okay, still starts in the middle, but now it would be going down. So first tiki mark, it's at its minimum. Next, back to the center line. Then to our maximum, then back to our center line. Oops, that's a dotted line. That's a very big dot to begin with. I'll take up no. There we go. So we draw it with a dotted line. That's the dash. Then finally we need to do a phase shift. It's plus pi over 6. Nice that I gave it to you in factored form. Remember, we always have to write in factored form. This one was already in factored form. But that plus pi over 6 would be a shift to the left. On my axis, I already have what 1 pi over 6 is. So negative pi over 6 would be exactly that same distance to the left. And I'm going to take each of my points and shift them then 1 tiki mark over to the left. And this is my final graph. Check mark on the C. We've done every part. So with that, we can go to example 1. First of all, we're going to change it to say at least 1 period. So in part A, when it says predict, it's sort of like a describe question. If you had to compare these two, what could we say about each of these numbers? This 1/4 would be a vertical compression if we were using our language from the first unit. We could also say that the amplitude is 1/4. That's using some language from this unit. So we have a vertical compression, you multiply your y values by 1/4. What's that going to do? It's going to change your amplitude. The 3. That 3 would be a horizontal compression. If we used our language from chapter 3, you multiply everything by 1/3. In this unit, it tells us our period is equal to 2 pi over your b value, 2 pi over 3. Next, the pi over 6 is a horizontal translation. Pi over 6, x's are still liars. Pi over 6 to the left. And finally, the +2 is a vertical translation, 2 up. It means your center line or sinusoidal axis is going to be at y equals 2. And technically, we've already then listed the characteristics. So we're not going to do that again for part B. But now if you went to use that DAB-C to graph this, we know that our center line is at y equals 2. Check. Amplitude is 1/4. Oh my goodness, that's not very big. It means our maximum is at 2.25 and our minimum at 1.75. A part. All we use our A value for is to label our maximum and our minimum. We figured out our period was 2 pi over 3, so go on your x-axis, mark 2 pi over 3 somewhere, and divide it into 4 equal sections. Label those sections, so half would be pi over 3, half of that, pi over 6, and then this would be 3 of those, so 3 pi over 6, or pi over 2. B part is done. Next, the dash. Draw your graph with a dotted line without a shift. It's a coast graph. Where does a coast graph start? At a maximum. So I go start at my maximum. And it's not a negative coast graph. Does it make sense if it was a negative coast graph? It would start at a minimum. So it starts at a maximum. Then we would go to center line. Then to minimum. Then back to center line. Then back to maximum. A little skinny sinusoid. And finally, our phase shift, which is pi over 6 left. So again, I'm going to have to mark a negative pi over 6 on here. And take each of these points and go one ticky mark to the left. And we've graphed it for one full period. So, questions to circle. 3, 8, 9, 10, 11. And I had a note that don't forget to factor in number 11.